inside tree recursion, there is one pattern which is pick and not pick. And you people are like aware of this also, I guess. And this basically says that either you are going to pick a particular element or you're going to skip a particular element or a set of elements according to the problem. So this is the pattern that we are going to learn today, pick and not pick. So the very first problem that we're going to solve here is subset problem. Basically, it is a classic problem that is based on this pattern, right? So this is your subset problem. Subset problem says that suppose you are having multiple elements, right? So suppose you're having 1, 2, and 3. These three elements are there with you. So what you have to do is that you have to find all the subsets of this particular set. Now, what is called as a subset? So you say that suppose any set is there, and if it is containing a part of this particular set. So for example, 1 is basically a part of this set, right? Similarly, 2 is also a part of this set. If we'll take 1 comma 2, this is also a part of this set. So if any set is containing a part of the main set, then it is called as a subset. So we know the definition of subset as well. Now the question is that how many such subsets are possible for size 3? So if this question will come that how many subsets are possible, then you will simply say that if the size of the main set is 3, then there are 2 raised to the power 3 sets possible, like the total sets possible are 2 raised to the power 3. And if you'll do the collection of all these sets, like 2 to the power 3 subsets, if you will collect them all together and put them in a parent set, then that is also called as a superset. So the superset is basically a set which is containing all the subsets, right? All the subsets. And now our question is the same, which is to generate all the possible subsets of a particular set. All right. So we now understood the problem and how do we go for it? So we say that, see, this is a pick not pick pattern, which means that you have to start from an initial state, right? And at this particular state, you have to basically from a particular element as well. So you are starting from zeroth element, and either you're going to pick this element or you're not going to pick this element. So there are only two possibilities that you have to go with. So either you're going to pick this element or you're not going to pick this element, which is at I equals to 0. So now the set will become either 1 or it will become basically an empty set because you're not picking up 1. So these are the two possibilities that has come at this particular distance or this particular uh, length, right? Level. So at this level, we have either 1 or otherwise an empty set. In the similar way, now we will go to I equals to 1. So in this particular state also and in this state also, we will go for I equals to 1. So what is happening is, again, this particular state, a state is basically a function, right, in which we are exploring our options. So recursion is all about options. So you have to stand at that particular state and you have to think that how many options can we have. So we are thinking that how many options do we have from this state. So we are saying that for I equals to 1, either you're going to pick this is number or you are going to skip this number. So there are two possibilities. Then again, we'll say that if you're picking this number, then the state will become 1 comma 2 for the subset. And if you're not picking, then the state will become 1. And in the similar way here also, so either you're picking this number, which is 1, so which is 2. So either you're picking the element at index number 1 or you're going to skip it. So it'll be the same. And similarly, here you're going to work on I equals to 2, which is either you're going to pick 3, which is 1 comma 2 comma 3. This is how your subset will look like in this particular state, or you're going to skip this state. So if you're skipping it, then the state of your subset will be 1 comma 2. And in the similar way, here also either you're going to include it, so it is 1 comma 3, or you are going to skip it, so it is going to be 1. In the similar way here as well, so either you're going to take this 3 inside, so 2 comma 3, or you're going to skip it. So it is going to be 2 only. You're not including 3 for this particular state as well. And in the similar way, the last state as well. So either you're going to include it or you're going to exclude it. That is, you're not going to consider it inside this set. So it will be empty. And these final states are basically like if we'll collect all these final states, then this will make up our these final state will make up our superset, right? That is containing all of these states. So this is your subset problem. So I think that this is clear.
Yes, ma'am.
And it is very simple also, right? Now the thing is that we want to implement this in our program, right? So we do understand that how this state space tree works, but now we want to implement this. So while implementing your question, what you have to do is you always have to practice this, that you have to pick any one of the states. So suppose we are picking up this state, you have to just think about it, that how to implement this one. If you can implement a single state, then it is very simple, because for all the other states, whether you're talking about this state, or any other state, so whatever your recursive function is doing at this state, it is going to do the same task at this state as well, at this state also, because recursion is all about repeating a single task. So recursion is all about repeating a single task, right? So whatever single task we have initialized or we have assigned to I equals to 0 or the first state, that same task has to be done by all the function, all the intermediate states as well. So you have to always think of three things. Whenever you're writing a recursive function, you have to always think of the three things. The first thing is that what is that a smaller task that a single recursive function is doing? So a smaller task has to be decided first. Now, what is this a smaller task doing? So we will say that this a smaller task is basically generating two states. So what is it doing? It is doing basically, it is doing a call of two states. That is, either it is going to include a particular index or it is not going to include the particular index, right? And it is making two calls. So this is the small task that this particular state is doing. Then the second thing is that what is the data that has been exchanged with this state. So you'll say that an array is being exchanged every time a function is called, right? So an array or a list has been exchanged every time, and then another thing that has been exchanged every time is this index, because at the first state you were working on index number 0, then you came here and you were working on index number 1, and then in this state you were working on index number 2. So every time you are also working on index. This is also a data that has been exchanged every time. So these are the two set of data values which are being exchanged by different state with each other. A smaller task we have decided. And the third thing that you have to keep in mind while writing a recursive function is your terminating case. That is, what is that particular case where we have to stop? So we'll say that when I is equals to 3 and basically I equals to 3 doesn't exist for this particular array. So this is the case where we have to stop somehow, because we will not get any element at I equals to 3, because there are only three indices available, which are 0, 1, and 2. So we have to decide on our terminating case also. So whenever you're writing a recursive call, these are the three things that you have to always think of. Now, after knowing this thing, if we want to implement this complete thing in our, code, so how would we write it? Because we want to write it, right? So let us open Visual Studio Codes. So Visual Studio Code, and now we are at the implementation part, obviously. So let us open our folder, which is here. And now we are saying that, okay, now let us implement this as well. So, all right, let us do that. We are saying that this is our new file, and we are saying that this is your pick and drop, so subset printing program. And here we are going to write that this is our class subset, and then this is our main function. And inside the main function, we are saying that suppose we are having an array in which we are having 1, comma 2, comma 3, these three elements. And now this helper function we want to call. So at the first point, we have to decide that what is that data that needs to be exchanged. So we just now decided on that there is a list that needs to be moved to the different state so that that can be filled with different elements. So we are saying that we need a array list, right, or a vector. So array list, and then it is going to contain integer type of elements. And then the name of the list is suppose list and new array list. So this is how we have initialized our list. And afterwards, we're saying that we need to pass this list, of course, because this is a thing which we need to fill in all the states. Then obviously we need options as well, that what is that particular element that we are filling into this list. So for that, we need an array and obviously the index as well. So these are the three things that we think initially of while exchanging the data. And if something will come again at the time of while we are writing the code, will include that as well. But right now I can think of only these three things, and I'll say that okay, let us implement it. So it is not going to return anything as such, so that's why void. And afterwards the name of the function, which is helper, then one array is going to be there, which is arr, and then what is the index that you're working on in this particular state. So you'll say that this is being reflected inside the in variable, and there is a list as well. So array list, right? And this is of type integer, and the name is supposed list. Now we have to implement a single function. So we are looking at a single function and we are saying that we have to pass an array list. So we have passed it. We have to pass array list because you can see that this list is basically growing at all the levels. So it is, it is having only one element in this state, then two here, then three here. And it is not of fixed length. So sometimes it is empty, sometimes it is containing one element, sometimes two. So that's why it is dynamic in nature. So that's why we are taking a vector or array list in this case, so that we can, fill it up and then remove some elements from it. Afterwards, we also know that we need an index and then pick and not pick the main logic. So we are saying that at first, what you can do is that you can fill this list with this new element, which is represented by in index. So you're saying that list dot add this new element, which is at arr index. So you're including this inside this your list, and then you're calling your helper function, and inside this you're passing arr, then index plus one, and then the last thing would be your list. And when you're coming back, so whenever you come back, what happens is that if you have included three in this state, then whenever you come back, you need your previous state back. That is, you have included three in this state, but when you come back to the previous state, because you need to call another function as well. So at this state, you have to remove this last element, which is added, right, at the end. So we need to remove this element as well. So we are saying list dot remove, and which element do we need to remove? So list dot size minus one, which is that or whatever is the last added element into the list that we need to remove, nothing else. And afterwards, so this is basically a call which is made for uh, including a particular element, and then you have to not consider the element also. So there are two cases. So the second call to the helper is for that particular state. So array, then index plus one, and then the list, just like this is passed. So these two calls are made. This first one wherein you are including a particular element, and this second one where you are not including that element. And that's it. At the end, we are saying that what is the terminating case, because we need to, uh, you know, basically stop this ongoing calls as well. So we are saying that as soon as the index value is equals to array dot length, we can stop this process because any which ways we are not having this element. So here we can simply print out our list current state, and then we can return from here. Return simply means that return the control, do nothing. And this is it. So now if you'll see that what all elements are there in the list. or what all states list was maintaining. So these were all the subsets that were there.